The following is an illustration of an apparatus for examining the type of charge of cathode rays. The first component is a closed glass tube. The air inside has been pumped out. So inside the tube there is a vacuum, or has very low air pressure. Can also be called a gas discharge tube. The metal plate on the left is connected to the negative pole of a DC voltage source, referred to as the cathode. The metal plate on the right is connected to the positive pole of a DC voltage source, referred to as the anode. Inside the tube, there are two circular filters, where in the middle, there is a horizontal hole. This filter functions to filter the direction of the cathode rays. Thus, the cathode rays that pass through the inner area of the tube are only cathode rays that have a direction parallel to the x-axis, or horizontal axis. Between the two filters, there is a fluorescent sheet. Fluorescent sheets will emit light when touched by radiant energy. These are some of the important components of this experiment. After all the circuits have been connected and turned on, light radiates on the fluorescent sheet from left to right, or from the cathode side to the anode. This experiment once again confirmed that cathode rays did come from the cathode. The luminescence was in the form of a straight line. This is a phenomenon seen during the experiment. We will explain this in more detail later. Now, two parallel plates are installed vertically, such that the gas discharge tube is between the two plates. This plate is shaped like a thin block. The top plate will be connected to the positive pole of the voltage source. Meanwhile, the bottom plate will be connected to the negative pole of the voltage source. The vertical plate voltage source is different from the voltage source from the cathode and anode. Thus, the vertical plate does not emit cathode rays. Once the circuit has been connected and turned on, the cathode ray glow curves upwards. If the poles of the plate change, the luminescence of the cathode rays also changes. Now the curve of the light goes downwards. From here, we can see that an electric voltage plate can deflect the movement of cathode rays. Why is that? Here is a simple view of the apparatus. There are cathodes, anodes, filters, and fluorescent sheets. The cathode emits cathode rays in all directions. The shape of the trajectory is a straight line in accordance with previous experiments. However, not all directions of these rays can pass through the filter. Only cathode rays have a direction parallel to the horizontal line. When the cathode rays touch the fluorescent sheet will emit light. This is a concept that must be understood first. When there are several cathode rays entering the filter simultaneously, the cathode rays will touch the closest fluorescent sheet first. That's why we see light flashing from left to right. Because on that side there is a fluorescent sheet closest to the cathode ray source. So, now we know why the shape of the light beam on the fluorescent sheet is a straight line. To explain the next phenomenon, we will look at this equipment from the front. Now, this tube is between two parallel plates. When the top plate is connected to the positive pole, a positive charge will form on the surface of the plate. On the other plate, a negative charge will form. Based on the concept of static electricity, an electric field will be formed. The direction is from positive charge to negative charge. When all the electrical circuits have been connected and turned on, it turns out that the luminescence curves upwards. What does it mean? Meaning the cathode rays have a negative charge. Because negative charges will be attracted towards positive charges. If the pole of the vertical plate changes, the cathode rays will curve downwards. This proves that cathode rays have a negative charge. From this experiment, we know that cathode rays are affected by an electric field and have a negative charge. Thank you for watching this video in full length. And don't forget to watch the next video.